We all build and use services. One of these services is the DNS. DNS stands for Domain Name System. The DNS is just a service. It's built its own protocol for us in order to resolve keys of a map to their values. So you can think of a DNS as a very distributed map, which gets billions of queries, millions of writes, and it needs to be a very high-scale service. It's spread all around the globe. It needs to withstand security attacks, and it needs to serve all of us, everyone who is using the internet, and also other servers. As top-tier on-call programmers, we need to understand it better, at least the basics. So let's move ahead with it. So as we said, the DNS is a service that is spread globally over the internet. You can think of the DNS as a map. It's a map of items. It serves, of course, conversion in between a name, a domain name, let's say brother.com, into its IP address, because IP address is friendly to computers. Computers love numbers. But we humans, at least many of us, less like numbers and prefer to use the web address brother.com. It's not just a simple map. On top of the map that you serve because it needs to be globally, then there is a data structure of a tree. The tree is a tree of servers which host the DNS service. It's actually an inverted tree because when you make a call to one of these services, then you make a call to one of the leaves of the tree. And if these leaves does not know the answer, what is the value of the key of this map, then it would move ahead into an upper layer. So basically the DNS does not only serve resolving IP addresses for websites, also for emails. When you send an email, you specify the string of the email. Let's say someone.gmail.com, but for which server does it resolve? This is one of the targets of the DNS. The DNS uses the UDP protocol, and it's a huge distributed database. The DNS has a few records for each entry of a domain name. It has the A record, which is the most basic conversion of a domain name to IP. It also has the CNAME entry in the map, which converts an alias into your domain. It has the MX, M stands for mail, which converts when you send an email. It uses this entry in order to get the actual host. For example, for Gmail, it's ghs.google.com. So you didn't send an email to ghc.google.com, so someone needs to resolve it. This is the DNS. It serves a huge amount of requests, billions of requests. It's a very critical system. Without it, the internet would be basically shut down, just as the economy have shut down with the coronavirus. So it needs to support scale, security, and attacks. Even a basic DDoS attack, just as for any other server, could shut it down. So we need to know that DNS is just a standard service. And how do you design and scale such a huge, scalable, with such huge requirements service? Then first, I think the first layer is the cache that you have on your file system, the host. And then you have another layer of cache that you have on your browser. So you see, many of the distributed servers that need to serve so many entries need to start doing some tricks. And a trick is a cache, because a cache is complex and you need to update it. So this is a trick that DNS uses in order to serve you well. In addition, the DNS uses a very big tree structure where you first go into a recursive server and you try to fetch the name from there, and if not, then you move on to the top tier servers. The CNAME entry that we said, which is an alias, sounds very good because this means that you could map like additional human-friendly entries into the IP, but it's only for subdomains. The DNS protocol is actually part of the TCP/IP suite of protocols. It's like a basic phone book. So when you have your local cache, it's like you are opening your phone book. But of course, it's not enough, because if your phone book is out of date, then you need to access external layers in order to get the actual values. The DNS actually maps just between host names and IP addresses. It also has a reverse map from the IP into the host name. So it's basically a distributed map. And you can make all the tricks. You can start when you create a DNS system. You can start thinking of, how do I serve request? How do I distribute a request in between my servers? Because if I get too many requests, then I have multiple servers. And if you have multiple servers, then you need to think, do I serve them randomly for each server, just as any other service? Or do I do some kind of sharding in between the server? There is also the AAA record, which stores conversions in between domain names into IPv6, because we said that the A record contains the conversion, the mapping between the domain name into the IP. So this is IPv4 and the AAA is to IPv6. So basically when you have a request, then you go into the recursive servers. The recursive servers are the servers which are in between. This is just the name that we give them. So with that, I think we can summarize our quickie of today, which was about the basics of a DNS server. The basic records that it stores, the AAA for IPv6, the CNAME, which is an alias for subdomains, the MX record for mails in order to know which servers to get to. And also we need to remember that basically DNS works only because we believe it, because we say that we all agree that the root servers which provide the basic DNS, we just believe in them and we say, yes, you are the authoritative server, So we are going to trust you, because you could, for example, say, okay, my DNS does not trust the authoritative servers, and from now on, brother.com points to a different IP. You could do this, but the whole internet believes in those authoritative servers and it's using them. It's replicating its data into their recursive servers and into their cache. Therefore, the convention of the DNS, the convention of the authoritative servers, the convention of the intermediate servers, where each layer calls the next layer, this what provides us with the DNS and basically also the internet. So I think this was very interesting. If you have any comments or suggestions, please post them through Apple Podcast reviews and I would read them there. Thank you for listening and I'll see you next time.